Hello everyone. So today we will continue our session on hypothesis testing. So today we will understand how to develop a hypothesis. In this session, we will look into how to develop and refine hypothesis, and basically we will look into like what is a null hypothesis and what is its purpose. Before going into the null hypothesis and its purpose, let us first look at the key terminologies. So the first thing is about developing and refining hypothesis. So developing hypothesis is a crucial aspect of any research because the research is guided by the hypothesis. So based on this, data is collected from the participants and data analysis is carried out. So this involves the following steps. The first one is identifying a research question. So basically, whether it's a research question or it's a research problem. So the researcher starts by identifying a specific research question or problem within the field of interest. Then a literature review is conducted to understand the prior research done in similar areas and also to see whether the same research has been conducted or not, so that it is not a repetition of a prior research. So the researcher basically conducts a review of the existing literature to understand what is already known and identify gaps or areas that require investigation. Then the next step is formulating a tentative hypothesis. So based on the research question and the literature review, a preliminary hypothesis is created. So in this, the hypothesis is created based on existing knowledge. So we should always remember that hypothesis testing is carried out in generally quantitative research where there is already some knowledge developed and we want to test a specific relationship. So the preliminary hypothesis is formulated after conducting the literature review. So this should be a clear and testable statement that proposes a relationship between variables or an expected outcome. Then the next step is operationalization of the variables. So this means that the different variables, that is the independent and dependent variables, are identified, and the researcher specifies how the measurement or the manipulation of these variables will be carried out. So basically, the researcher will define whether they want to carry out a predictive relationship, such as those used in multiple regression, or an association test, such as the correlation test. Or it can also be an independent t-test, where two samples are tested to see whether they differ from each other. So the operationalization of the variables is carried out after defining the hypothesis. And then alternative hypothesis. So in academic research, it is not always the linear path is followed, but alternate paths are also to be followed, wherein the researcher needs to think critically about alternative hypothesis or explanations for the phenomena that they are studying. So it helps in refining the hypothesis and consider alternate possibilities for the relationship that is being tested within the research. And then we have refining the hypothesis. So the hypothesis is continuously refined, and it is important to clarify what the hypothesis is and to make it more specific, focused, and aligned within the chosen area of research. And then the next step is pilot studies and expert input. So in some cases, conducting pilot studies or seeking input from experts can help refine the hypothesis and ensure its validity. So now we come into the concept of the null hypothesis. So in statistics, you will come across a lot with respect to the null hypothesis. So it is the basic level of hypothesis testing. So what is a null hypothesis? So a null hypothesis is a fundamental component of hypothesis testing, which represents the default or status quo assumption that there is no significant relationship or difference between the variables. So that is the general null hypothesis. So whatever variables you're testing, the null hypothesis is that there is no significant relationship between the variables. So in essence, it assumes that any observed results are due to chance or random variation. So that is the definition of null hypothesis. Then what is the purpose of null hypothesis? So we also studied in the last session what are the different characteristics of a hypothesis. So the first one is testability. So a null hypothesis is designed to be testable. So by using statistical techniques. So it proves the framework for assessing whether the observed results are statistically significant or whether the result is due to the, or it is simply a result of random chance. So researchers use statistical methods to determine if they can reject the null hypothesis in favor of an alternate hypothesis. So just to remind, a null hypothesis is rejected when the significance level is more than 0.05. So in that case, alternative hypothesis is accepted. When the significance level is less than 0.05. But when the significance level is more than 0.05, the null hypothesis cannot be rejected. So the next purpose of hypothesis testing, null hypothesis is control, which means that by assuming no effect or relationship, researchers ensure that their hypothesis undergo rigorous testing and scrutiny. So it essentially means that the researcher should carry out different statistical tests to understand the relationship between the different variables. So it establishes a baseline for comparison and helping researchers to avoid premature conclusions. So whatever conclusions or research findings that the researcher arrive at, it is based on your mathematical and scientific analysis. Then the third purpose of null hypothesis is the basis for inference. It means that the null hypothesis serves as a basis for making inferences about populations based on sample data. So the researchers assess whether the data provides sufficient evidence to reject the null hypothesis and support an alternative hypothesis indicating a real effect or relationship. So whenever you are formulating a null hypothesis, you should remember all of these characteristics, which is testability, control, and basis for inference. Now we look into using examples how an hypothesis can be identified. So remember, always remember that formulating a hypothesis is a first step, and it is the most important step in conducting a quantitative research. So the first step is identifying a hypothesis involves recognizing a specific statement or proposition that suggests a relationship between the defined variables. So you can have like two or more independent variables and a dependent variable. So you can use a multiple regression test to carry out a causal investigation, that is how each of the independent variables they impact the dependent variable, or you can use a correlation test to see how the strength of association between the defined variables. So so we will look into few examples of how a hypothesis can be identified, followed by references. So the first example is medical research. So here you can have a research question such as, does a new drug reduce blood pressure in hypertensive patients? So patients who are suffering from hypertension, so does the new drug reduce blood pressure for those patients? So in this, how do you identify the hypothesis? So the hypothesis is identified as the administration of drug X to hypertensive patients will result in significant reduction of blood pressure compared to a placebo effect. The placebo effect is where a patient is given a simple formulation with no medical combination, just to see the impact on how the body reacts. So here you formulate the hypothesis is the administration of drug X to hypertensive patients will result in a significant reduction in blood pressure compared to a placebo. So in this example, the hypothesis suggests a causal relationship, which means a predictive relationship between administrative drug X and a specific outcome, that is reduction in blood pressure. So here, if you have to formulate the null and alternate hypothesis, it would be, the null hypothesis would be there is no impact of drug X on reducing blood pressure in hypertensive patients. Whereas the alternate hypothesis would be there is an impact of drug X on reducing blood pressure in hypertensive patients. So that is how your hypothesis is formulated. Now let's look at example 2, which is in psychology research. So here the research question could be, does sleep deprivation affect cognitive performance in students? So basically it is that students who sleep less, they perform worse as compared to students who sleep normal in their performance. So how do we identify the hypothesis? So the hypothesis is students who are sleep deprived will perform significantly worse on cognitive tasks compared to those who have had adequate sleep. So this is the hypothesis. So in this hypothesis, it is assumed a relationship between independent variable, which is sleep deprivation, and a dependent variable, which is cognitive performance of students. So again, this is how you develop or formulate a hypothesis. So next we look into an explanation on how to formulate a hypothesis. So formulating a hypothesis involves crafting a clear and testable results. So statement, sorry. So you should be totally aware that when you are formulating a hypothesis, you should have variables, and then you should work towards testing the relationship between the variables, and which expresses a proposed relationship between variables or an expected outcome. So that is the main purpose of hypothesis testing. So some of the steps which can explain how to formulate a hypothesis are detailed out. So the first one is identify the research question. So we already went through this, and then reviewing the existing literature, wherein a thorough literature review is conducted on what is already known about the topic, and so that it helps in identifying the gap in knowledge and the potential areas for investigation. Then we have choosing the variables. So the variables need to be determined, like the independent and the dependent variables need to be determined. This is done based on a literature review, where you identify the independent and dependent variables, and then you give a clear direction to your research. And then the next step is define the directional aspect. So here you need to decide whether your hypothesis is directional, which is predicting a specific direction of effect, or non-directional, which is predicting that a relationship exists without specifying the direction. So the directional effect is important when formulating a hypothesis. Then you need to formulate the hypothesis, which is to write a clear and concise statement that articulates the expected relationship between the variables. So we have seen a few examples, like there is an impact of drug X on reducing blood pressure in hypertensive patients. So that is one clear example which we had said. Then the next step is to follow proper syntax, which means that you need to follow a standard format for hypothesis, which often includes the use of conditional words like if and then. For example, if independent variable increases, then dependent variable also increases. So this is an example using a correlation test. And finally, you should ensure clarity, which means that you should make sure that your hypothesis is clear and unambiguous. It should be easy for others to understand and test it. So that is how you explain and formulate a hypothesis. So again, let's look into it with an example. So let's consider a research question in the field of education. Does the use of interactive online tutorials improve student learning outcome in mathematics? So this is the research question or the research problem, like whether online tutorials helps the students in improving in mathematics. The formulated hypothesis is if students use online tutorial in mathematics, then the learning outcomes will improve compared to students who do not use these tutorials. So this is the directional hypothesis, and you have a clear and testable statement using the formulated hypothesis. So next we look into the purpose and formulation of null hypothesis. So the null hypothesis is a fundamental component of hypothesis testing, like we already studied before. So it serves the specific purpose and is formulated to provide a point of reference for statistical analysis. So here we explain the purpose and formulation of the null hypothesis. The first purpose is control. So a null hypothesis is to establish a baseline assumption that there is no effect or relationship between the defined variables. So by assuming no effect, the researcher create a controlled environment for hypothesis testing. So you should always remember that a hypothesis testing is carried out within a controlled circumstances, by selecting a small sample. So this ensures that conclusions are drawn based on empirical evidence rather than on preconceived notions. So that is the whole concept of establishing control over the testing of the hypothesis. Then the next one is comparison. So the null hypothesis provides a basis for comparison with the alternative hypothesis, like whether you have to accept the null hypothesis or whether you have to reject the null hypothesis. So researchers analyze data to determine whether there is sufficient evidence to reject the null hypothesis, which means that the significance level is less than 0.05 in favor of the alternative. In this way, the null hypothesis facilitates an objective assessment of the research findings. So always remember, you will reject the null hypothesis when your significance level is less than 0.05. Then testability. So the null hypothesis is designed to be testable using statistical method. So it allows researchers to assess the likelihood that observed results are due to random chance rather than a meaningful effect. So by assuming that the observed results are random chance, it provides a quantitative measure of this likelihood. So by using statistical techniques or scientific techniques, you can actually say that you have tested this proposition or you have tested this hypothesis, and the research findings that you have presented is based on this, based on the empirical evidence. So the next is formulation of null hypothesis. So the null hypothesis is typically formulated as a statement of no effect, relationship, or difference between variables. So its structure, it actually varies depending on the research question. For example, one null hypothesis could be like there is no impact of spending of marketing budget on say increasing brand visibility. So what you can do is when you test the data, you find the result that spending more leads to higher brand visibility. Then in that case, you reject the null hypothesis and you accept the alternate hypothesis. So here we have provided some example like equality. So null hypothesis often express that there is no significant difference or effect. For example, there is no significant difference in test scores between group A and group B. So again, the null hypothesis is designed based on tests of equality. Then the second characteristic is no relationship. So in cases involving correlations or relationship between variables, there is no significant correlation between hours of study and exam performance. So this null hypothesis, it clearly states the principle of no relationship. Then you have no effect. So when examining the impact of an intervention or treatment, the null hypothesis can be formulated as a new drug. The new drug has no significant effect on blood pressure. So you formulate the null hypothesis as having no effect. Then you have equality of means. So in the context of means or averages, the null hypothesis is stated as the mean weight of product A is equal to the mean weight of product B. So when you reject the null hypothesis, it will be the mean weight of product A is not equal to the mean weight of product B. Then no change. So for experiments involving change over a period of time, so basically longitudinal studies, the null hypothesis is formulated as there is no significant change in plant growth over a course of 1 month. So that is how we formulate the null hypothesis. So the null hypothesis is usually denoted as H0 or H0, and its formulation is specific to the research question and the variables under investigation. So when you're formulating the null hypothesis, you should remember that you have clearly identified the variables, and if you're testing the relationship, then your null hypothesis should be there is no relationship between variable A and variable B. So that is how you formulate the null hypothesis. It represents the default or status quo position that researchers aim to evaluate through statistical testing. So in conclusion, so what have we learned about null hypothesis? So null hypothesis, it essentially serves as a control and comparison point in hypothesis testing. So it is formulated to assume no effect, relationship, or difference between variables. So these are all important characteristics, and it provides a structured framework for objective assessment based on empirical evidence. So based on the statistical testing or any other scientific testing methods, you arrive at the result which you present in the findings. So therefore, hypothesis testing is very crucial, and it is the first step for presenting empirical evidence of your studies. So that is all for today. In case if you have any questions, you can let me know.
Thank you for the lesson today. Do we have any